Hello, it's Stat 134, Lecture 38. Last time we started section 6.5 on the bivariate normal. Remember that the bivariate normal is constructed by having two IID standard normals, which we look at their joint distribution in the plane, and we rotate that plane by minus theta, and then the x-coordinate of the rotated point, which we called x theta before, which we're now going to call y, is cosine theta x plus sine theta z. And we write rho for cosine theta, so that's a number between -1 and 1. So the joint xy is the standard bivariate normal, and it has various properties that we discussed last time. For one thing, y is standard normal. The correlation between x and y is rho, and y given x is rho x plus square root of 1 minus rho squared z, and that's a normal distribution with expectation rho x and variance 1 minus rho squared. So note that the variance does not have any dependence on x. So you can see that in the picture on the left. I've drawn a normal, so you fix x, and I've drawn a normal, which corresponds to the slice, sort of this vertical slice through a certain x value. And notice that the shape of that normal is the same for all the curves. There's just basically, for all the x, it's just basically, you just slide it down the regression line. And because the width is the same, basically plus or minus 1 SD around the regression line is a band of constant width, and that contains 68% of your data. So the regression line, we often write it in as y hat equals rho x. That's the regression line in standard units. And today we're going to look at student explanations of the concept test from last time. We're going to practice with the bivariate normal. We'll talk about the regression effect, and then we'll do some more practice. Next time on Monday, we're going to finish 6.5 and start our review. So last time we did this problem where students are picking out 10 green marbles each, and we were wondering whether to find the correlation of x1 and x2, whether the sum x1 to x9 equals 20 is a true identity and a useful one. And so the answer was yes. And so one person says the variables aren't interchangeable. That is, the second and third distributions depend on the previous ones, but that's not in fact true. Although, I mean, there is a dependency between them, but they are interchangeable. Let's read below. Because they draw without replacement, the total number of all green marbles that can be drawn is 20. Since all 90 marbles are drawn in x1 to x9, we know all the green marbles are drawn in these 9 draws, and draws are exchangeable with when considered unconditionally. Thus the correlation is -1/8. The derivation of the correlation without the identity uses the method of indicators. Okay. It's a sum of exchangeable random variables because you don't condition on the first draw. The sum has to be 20. So that's right. So we are not conditioning on the first draw. So in fact all x1 to x9, they're all hypergeometric. with the same parameters, and so the probability, say that x1 draws 5 is the same as the probability that x2 draws 5. Okay, so on to bivariate normal. So imagine two test scores are bivariate normal where the rho is 0.6. Given that the first test is at the 80 percentile, predict the percentile of the second test. Okay, so we find the test score in standard units using our normal table or inverse CDF, or in R you can write Q norm 0.8. So that gives us 0.84. And then, so I draw my bivariate normal, and I want to find basically the height of the corresponding point on the regression line. So I just stick 0.84 into my regression line, and I get y hat is 0.5. And so now I just need to convert that to a probability. So I take phi of 0.5 and I find 0.89. So a score of 0.5 in standard units for test 2 is only the 69th percentile. Notice that that's less than the 80 percentile that the student got on the first test. So that's actually called the regression test. You will not do as well on average on the second test as on the first test. So the regression line now for when you're not in standard units. So in applications, you often aren't given x and y in standard units. So now we know the regression line in standard units has slope rho and no y-intercept. So we can write y minus y bar over standard deviation of y is rho, x minus x bar standard deviation of x. And just rewrite that to get the regression formula highlighted at the bottom here, where the slope is sdy over sdx rho, and the y-intercept, this should be a minus. So the y-intercept is what's shown here. And just a fun fact is that you can write the slope of the correlation. The slope of the regression line as the covariance of xy over the variance of x. So great. So I had you do a practice problem here, and let's see what happened here. So I gave you test 1 with a certain mean and SD, and test 2 with a mean and SD with rho 0.6, and I asked you to find if you get 70 on test 1, what would you predict to get on test 2? And you said it was 66. So you do not do as well on test 2, and that again is the regression effect. So to discuss the regression effect, we introduce the SD line. So the SD line is basically the line that goes from the tip of the football to the other tip of the football. So it's a line that has slope sdy over sdx, and I've given the equation of the SD line in the top highlighted equation here, or in standard units it just has slope 1. So notice that it is steeper than the slope of the regression line, which remember was sdy over sdx times rho. Okay, so the regression effect basically says that although you expect for a given x value, expect to go up to the SD line In fact, you only go up to the regression line. But there is a silver lining to this. If you are below the median, so you're on the other side of the y-axis here, so that means that you're below 50 percentile. You expect to get below 50 percentile, but actually you'll do better. You will not go all the way down to the green line. You'll only go to the regression line. So you'll do better. So again, here in red, you can see the regression effect, which is a good thing if you're not doing well in the class, but if you're doing well in the class, it's a bad thing. Okay, so then we did a concept test, and here it asked a test score in math and physics is bivariate normal with rho greater than 0. The average is 60 on both tests, and the SDs are the same. Of course, of students scoring 75 on the math test, what turns out to be true is that less than half scored over 75 on physics. So to see that, draw your bivariate normal. And so the SD line and the regression line cross through the point of averages, 60-60. But for getting 75 on math, so we know that the distribution of physics scores is normal, and it'll be centered at where the regression line, at the height of the regression line for that x value. And so that will be, so getting more than that value will be 50%. So the area under the curve in yellow is 50%. Now, because the SDs are the same here, so the student scoring more than 75 on physics is the area in black here, and so that's basically where the SD line crosses through the line for where math is 75, and you can see that area will be less than 50%. So the opposite happens if you're looking at 45 as a score. So now the area shaded in black will be greater than 50%. Okay, and then we've finished with one more practice problem. So this one's sort of being a geometric one. So x and y are standard bivariate normal. Rho x is greater than 0. So you want to find the probability that x is greater than 0 and y is greater than 0. So we wrote y as in terms of x and z. And so we're able to find the probability in terms of x being greater than 0 and z being greater than this constant times x. So notice that now, because you've put in terms of x and z are uncorrelated, and hence the joint distribution of x and z is the uncorrelated bivariate normal, and that's sort of like a bell shape. That's a bell shape distribution, and so we can pretty easily now find the probability that x is greater than 0 and z is greater than minus rho over square root 1 minus rho squared x. So it'll be the proportion of the plane shaded in the gray. And so that will be the fraction of the angle